let us now go to we are taking the same problem, the same network we took in problem 1, but we are going to go with 2 resources. Okay, we are going to now, we remember we had this problem with trucks as a resource. I am going to now add worker as a resource. Okay, and you have solved the network, so I am not going to ask you, and you are familiar with the network, that is why we are taking this problem. Now we are going to look at multiple resources and the possible conflicts multiple resources can cause, and I am limiting now the same 10 trucks and 15 workers. Okay, so we are limited to the same 10 trucks and but 15 workers. Remember, this was the network. Okay, and I am going to the spread. So this is the resource loaded Gantt chart. What you have here, let me explain this. You have the bar chart, this is for resource 1 for trucks, this is for resource 2 for the workers. Okay, so you can see that this is the early start schedule. Okay, and you have the trucks, so you remember we have 10 trucks, 15 workers. The trucks are over allocated. No, workers actually have 15. Let us understand the network. We've seen the CFG, so we have C, F and G. Sorry, CFG is the critical path. So you will find that C here it's highlighted in red. Okay, so A, B, C, F and G cannot be moved. Okay, all of the other activities have float, and when you look at D, it has float all the way till the end. Okay, we have, and then E right now has no free float unless H moves. So to get any float for E, I have to move H, and H moves only up to 40. Okay, let's go to the spreadsheet, and so here is the spreadsheet for this, and actually this also goes out. So you can see these are the critical activities we have here, which we cannot move, and what we have here right now is D has shifted. So now so in the early start solution, what did I have? I had D here, yeah, in which case, and I have to go down here and shift D2. Okay, so in case I forget to do that, remind me. So this is for each of the resources, and we had, you can see that we have, yeah, so we had 14 trucks and 13 workers. My truck is over allocated because I am only allowed 10. Okay, so now my first reaction, at least as a simple, might be to go to the late. Okay, if I just do that, how am I? That's fine. Yeah, but no, but I have to do this too. Okay, so now my trucks are okay, it's within 10. Yeah, the workers have exceeded my 15. So you have conflicting resources, not conflicting resources, you have two resources with the balance conflicting. If I balance one, the other seems to be unbalanced.
What was the relationship between trucks and workers?
There is no relationship between trucks. They are independent.
Then why did you move workers?
No, because I have got this. I have got this in two. No, that's a question you need to ask, because that's I've modeled this as two parts of the spreadsheet. One showing the resources of trucks, the other showing resources of workers. If I could pull this and this would automatically go with a macro, I would have used it, but I am just using it in this form for now.
So if both the resources are in relation, in a spreadsheet we can replace one with other.
Absolutely. I could just use a factor for that. Okay, so right now they are not necessarily related. For example, some might require 4 workers to load up a truck, other one might require just a backhoe, I mean a forklift operator, you might just need one depending on material or what you are using and things like that. So right now we are assuming there is no real relationship, but you have seen the problem which I am bringing up, that there are 2 resources, resolving the over allocation of one now causes over allocation of the other. Okay, so how do we now resolve this? So we again trial and error. Okay, is there a trial and error procedure I can use? So let's take this back. Let's take it back. So it's almost like a yeah, I have to change that. Okay. So E can now move because H is actually gone to the end. Okay. So let us, okay, so moving E to the late start, and it can move all the way to here. Okay. So 10, 11, yes. Okay, so the solution here is that I move H all the way to the end and then move E to the end. Now H is, now what has happened to my path now? Yes, E and H have become critical. Okay, in achieving that, E and H has also become critical. Okay, any other solutions? Okay, so right now we can't see anything else, but this is where an automated system would be useful. Okay, now for argument's sake, let us say that so we were able to resolve this with, you know, you can find a resource profile here. So for example, something here which will make it impossible, which will make it totally contradictory. The minute I resolve the worker issue, the trucks become over allocated, and there is no way, there is no solution possible within the floats. It's possible. Okay, it's possible. Okay, I'll give you an exercise later to work out which will contain such a situation. What do you do then? Yes. So one is to be able to go into multiple shifts of work, if that is possible.
If that is constrained, then I guess project duration will have to.
Yeah, or we remember the strategies we discussed earlier. I can say that I'm not going to, instead of taking, I can use my float to stretch out, either split the activity.
So that will depend on the activity.
It will depend on the activity. It will certainly depend on the activity, but these are potential strategies. Okay, I can take the float, I can split the activity, I can stretch the activity. So something like this, for example, so let's take here I need 4 trucks and I will finish it in 4 days. What if I give it only 2 trucks? Yeah, so if it's a linear assumption, so I can go with this saying 2. Okay, it might change certain things in some places, it might not, but I can go do that, and now it has actually brought my whole truckload down to 8 trucks. But it's a potential strategy which a project manager might choose to use, and this happens in reality. Okay, something is not available, they say let the activity continue, but we'll continue it at a slower pace. Okay, but the quantum of work will take longer to get done. Okay, the other option, like we said, is to take the 4 from here. I could move it elsewhere.
If you move there,
Okay, Now I have to obviously move this also.
If you change the
Yes.
it will exceed.
Yeah. So now the workers have exceeded. Okay, but these are I mean these are strategies which you have to do. And remember, when I moved it to 2 here, this will also, it will not stop here, this the bottom will also exceed. So let me go back to that. So here what did we do? We did 2, 2, in which case I would reduce this to, it's a strategy. Now I have to decide if that is workable or not. Okay, I will have to decide if that is workable or not. So these are the various options we have. Okay, so when we look at what we have covered today, we looked at resolving resource allocation problems. The basic way we learned is to use float to shift the activities. Okay, we also discussed that we can increase activity duration by reducing resources, and that gives us control on the overall allocation. Okay, and it's possible strategy. Another one is to decrease activity duration by increasing resources. Okay, we have not done this as an example, but you can visualize that this could also be done. Split activities, we have overtime of shift work where we are increasing effort. Okay, then other ways is to substitute resources. You say, okay, I am not going to use a truck, I am going to use something else, I am going to use people to shift what I am going to do. I have workers, I do not have trucks, it is going to be slower, but it is going to work for me. Okay, kind of a real thing. And finally, if you have no option, you increase project duration and kind of justify why the project duration is increased in this context. Okay, we need to cover more on this topic. In the next lecture we will take up mostly on the cash flow problem, but looking at cash outflow and inflow, and how do we balance our cash as a resource when we are looking at billing the client and spending on the work. Okay.